this is John Thompson, President of UniSci. Just giving you guys a sneak preview to our sensor configurator fluidics design program for sensors. With this program, you can configure various fluidic systems to provide fluids to our sensors and sensor arrays. Basically, the program is comprised of standard components here on the left-hand side, you can see. And in this small video, I'm going to be just making up a very simple, simplistic sensor calibration system. And typically, you would start off with some reservoirs. The reservoirs would represent each of the calibration solutions. You'd also start off with like a sample inlet and maybe a wash reservoir, along with maybe a 6-port valve. You notice that the 6-port valve has an address A1, and as you switch the valve around, the address changes, so then you can program it down here in the program. You probably also want to have some sort of heat exchanger, depending on if the water is coming in very hot from the sample. You can put a heat exchanger in, and maybe a check valve here for the outlets, along with you have to have some sort of pump here to pull it all through. And then of course you're going to want to select your sensor system. Sensor system here is a 1/4-28 manifold. I'm just selecting a standard one. And of course a waste container, maybe that's a peristaltic pump. If you have more than one peristaltic pump, maybe for an injection of say a colorimetric reagent or something like that, you can maybe put a syringe pump in there, maybe put some maybe put some waste in there, okay? And then you kind of plumb it all up, you plumb it all up with tubings, and of course each of these tubings and each of these reservoirs, all these components can be configured. They can be configured, and I'll show you how to do that very quickly here. Let's just say the reservoir is right here. This is the outlet to the valve. That maybe goes to the check valve. The check valve goes down here to the inlet of the sensor manifold. The outlet of the sensor manifold maybe connects to the peristaltic pump, which then maybe goes to waste. Okay, so that would be your fluidic circuit. And of course, as you change the valve around, you would basically be making and breaking fluid connections as required. Suppose you wanted to have a syringe pump here that injects a milliliter of colorimetric reagent in there, so that maybe you test it right here. Well, then you need to have a different component in the bottom here. So here I'm going to go like this, break that component here, and put a 3-port 2-position valve. And of course, it has another unique address to it, and you can address each of these components here on the fluidic program. And now I'm going to do some simple plumbing here. I'm going to put it also into that maybe the second inlet port, and maybe plumb up the outlet ports properly. You can see here there's a fluidic connection going on here, and maybe also, this is not waste, that would be like an inlet fluid, so I would have a reservoir there instead, and I'd have a waste container over here, of course, and just make and break fluidic connections. So you can see how easy this is. You can add in, for instance, a debubbler. Where would my debubbler be? Right up here. And make and break a fluidic connection. This always is a debubbler on the top. And then here's the most important part. Here you can have various sensors in the sensor array. Sensor 1, sensor 2, sensor 3. Let's just do 3 sensor array. You can also add in here just a standard, just a leak sensor. You can add in bulkheads here if you want to have this in a different container. There's a whole lot of different options. I'm just showing you some of the simplistic things that you can do with this. Now, if you want to configure each of these, it's very simple. Each of them has menus. Calib 1, so this is going to be Calib 1. I can have either a 1 liter container, and I can say it's at 25 degrees coming at the inlet. But at the same time, I can have something like from process would be the name, and I'd say I'd have 100 degrees coming in Celsius, and at say 10 bars, and then I'd have maybe water solution. Okay, and then I check out my heat exchanger, temperature incoming out. And as you populate these things, it allows us to engineer the system so that it will work with the components and they'll all work together. If you have a 200 degree in and you want a 100 degree out, obviously we'd have different connectors, different fluidics, different, maybe you'd use stainless steel systems instead of plastic systems and stuff like that. So yeah, that allows us to sometimes the reservoir volume here, say 20 milliliters. This really allows us, this heat exchanger here, the variable volume that allows us to really match it to the sensor volume here so that it can be injected maybe via syringe pump, the conditioned fluid directly from the heat exchanger into the sensor. And of course you'd want to have this heat exchanger take into account all the fluidic volumes from here to here. The other thing is, yeah, maybe you want to take and name this. Maybe you want to have a nitrate detector here. Instead of a lure sensor, you want a quarter 28 sensor, and not a temperature sensor. You want an ion selective electrode. I'll just put an arsenide on there as an example, even though it's not, let me see here, this would be nitrate, arsenate. Arsenate. And then arsenate. And I want a core 28, and this is an AIC. So you can see how these things configure these manuals along with the system fluidics. And then basically, as your fluidic circuit all designed, you can come in down here and you can say, okay, well, I want to take and first turn this this valve here at B1, and at time equals 0, I want to switch it to B1, okay? And then I want to take the 7-port 6-position valve, and I want to switch it to maybe this will be my wash fluid 5, A5, and I want to switch it at time equals 0. So basically that would be done initially upon initialization of the system. And then maybe I want to turn my peristaltic pump on, and I can take it. Here, there's different options, but I can address this peristaltic pump fairly easily. I'll just call it peristaltic pump A, and I want to turn it on, and I want it to go forward for a duration of 3 minutes. Now, I specified a flow rate here. You want to make sure that the flow rate time to time is going to equal flush volume. And we're coming up with calculators here so that some of this will be automated. So you can see that you're able to really go through and actually program it out and then visualize it as you're doing it. All right, so that's the bottom line. I hope you guys had a good time here looking at it. Hopefully you guys will be sending us all kinds of designs. Of course, we get the designs in, we give you guys quotes. They're low-cost quotes for either system integration or just components or whatever you guys need. All right, thanks a lot. Take care.